Hello everyone. In this session, we are going to discuss the basics of blockchain technology and how it works. So, what is blockchain? Blockchain is a technology which has gained popularity and huge interest advent of cryptocurrencies. Today, it is not only the backbone of the crypto industry, but also growing popularity for storing personal data, managing digital assets, maintaining supply chain for enterprises, and empowering computer games and metaverse. But what is blockchain? Let's discuss the technology in detail. As the name suggests, blockchain is a chain of data blocks. These blocks are stored on hundreds or thousands of computers distributed around the globe. Basically, blockchain is a digital ledger which holds all the credits and debits of any digital asset. That digital asset can be representation of any physical, such as pen or a chair, or digital, such as virtual currency or data or objects. Essentially, all types of objects, be it physical or synthetic, which have some value associated with them, can be represented as digital asset. Blockchain is a decentralized ledger maintained in a peer-to-peer network that stores and tracks one or more digital assets. When we say a peer-to-peer network, it means a decentralized network where all the network participants are connected in some way. In this network, each node maintains the ledger. This ledger can be compared to a bank account statement from day zero. Let's say you open an account, then the ledger will keep track of every transaction in and out of your account from the day of the creation of the account. Now, instead of storing this on a central server, the full ledger is saved to thousands of machines. Each transaction in this ledger can be verified at each machine independently, and it can be assessed if valid or not. Each block in the blockchain stores information of all valid transactions like its date, time, amount, and account involved. Blocks also consist of information about parties involved in transactions and the information that distinguishes them from other blocks. More like a unique code known as a hash that allows us to tell it apart from every other block. These hashes are cryptographic codes created by special algorithms. You might be wondering what is the relation between blockchain and cryptocurrencies. Blockchain is related to cryptocurrency, but it is not a cryptocurrency. In fact, cryptocurrencies are nothing but digital tokens defined as a number in the blockchain which are tracked from day zero. To understand this, let's take bitcoins. For example, bitcoins are just numbers which are stored in a blockchain ledger and which have been tracked since day zero. People need a digital number because there can be only one copy of it which reflects the fundamental nature of the currency. Let's say A has 100 and B has 0 bitcoins. A transfers 50 bitcoins to B. Then A no longer has 100 coins because the ledger gets updated, and it will remove 50 bitcoins from A's balance and add 50 bitcoins to B's balance, creating a single and secure copy. In a traditional system, a physical ledger is in the form of a book where each page contains the information as lines on the pages. Likewise, let's imagine a book is kind of rudimentary blockchain, where the pages represent blockchain as each page is connected to every other page through a page number. In a book, all pages are in a particular order. That's why if someone tampers with a specific page or removes any page, it can easily be noted since the pages are numbered and are connected to each other in a particular order. It is also easy to arrange the pages or the blocks in order and then identify any suspicious activity. This makes page number significant in a legal agreement or an MOU, as it helps the reader to understand if there is a page missing in the entire agreement. It is obvious that changing or removing a page can change the meaning of the whole agreement, and this is very important in the ledger as well. Removal of a page in a ledger can corrupt the entire ledger very easily. If we have an account statement that has 100 pages, and if someone removes page number, let's say 65, then we can quickly identify this, because the record will not be complete. If you compare blockchain to a book, you can find that the whole blockchain is equivalent to the book, of which each block is the same as a page, and each transaction in a block is the same as an entry on each page of the book. Blockchains record every credit and debit of the asset in the form of transactions, and store a set of these transactions in a block, such that any detail once approved cannot be altered without informing everyone in the network. This is made possible by connecting each block to the previous block. Let us know some history about blockchain now. As you all know, blockchain was invented by a certain person or a group of people known as Satoshi Nakamoto. When he released the white paper of Bitcoin named Bitcoin, a peer-to-peer electronic system, it was then everyone came to know about the form of cash that could be sent on a decentralized P2P network without the need for any central bank or other authority to operate and maintain a ledger, much as how physical cash can be. Although it was not the first decentralized currency that was proposed, the proposal solved several problems that this field was already facing in the past, and it is fair to say that Bitcoin is the most successful digital currency till now. Let us quickly go through some of the alternatives proposed in the past. First, in 1991, two cryptographers named Stuart and Scott proposed the secure chain of blocks. After a few years, in 1998, a computer scientist, Nick Szabo, proposed the first digital currency, BitGold, which used cryptography and hashing to store transactions digitally. Later, in 2008, Nakamoto introduced hashing and blockchain, keeping the system secure and immutable. Data on the blockchain that was impossible to alter. So, how does the blockchain work? We can define the blockchain as a system that allows a group of connected computers to maintain a single updated and secure ledger. Now, if users want to send or receive any asset on the network, they will require a wallet. It is a software that saves your private keys and lets you store, send, and receive bitcoins. Each user has a unique pair of cryptographically generated and connected keys are private in a public key. While the public key is known in the network, the private key is stored in a wallet. It allows only the users to be able to spend their bitcoins. Now users will create transactions. A block is created that stores these transactions. Each of these blocks of data is cryptographically secured and linked to the previous ones. Once the block is created, it is broadcasted in the peer-to-peer network to other nodes. Nodes present in the network then validate the block along with all the transactions it holds. Once it is verified, it is dependent on top of the existing blockchain. A transaction is thus made permanent, unalterable on the blockchain. A transaction can be simple transfer of cryptocurrency from one user to another. It can also be creating a new contract to ensure some rules. What is block in the blockchain? Blockchain is a chain of blocks in a ledger. Each individual block is uniquely identified by its block header. Transaction data is stored in a block body. The block header has the following components. Block version. Number of the block, which signifies the blockchain protocol incorporated in the block. Then is the Merkle tree root hash. Transactions are arranged as a Merkle tree to encode them securely and efficiently. Each transaction in the block is hashed and stored in a tree-like structure such that each hash is linked to its parent. Next is the hash of the previous block in the blockchain. This component makes the block connected to the previous blocks on the blockchain, having them all built on top of each other. This brings the connection and chronology between each block. Next component is the n bits. It is an encoding of the block target. For a block, a target is the threshold hash value determining the block validity. A block will be valid only if the hash of its header is below the target value. Then there is not stored in the block header. It is a variable decided by the miner creating a block. In order to keep the block hash under target value, the miner guesses the nonce value. This is the work a miner has to do to produce a valid block. The process is called proof of work. Block header also has a Unix timestamp value. It serves as source of the variation of the block hash. So, what does a blockchain look like? The first block of a blockchain is Genesis block. The Genesis block is called the day zero block or block zero. It is the block that will contain the starting balance, which can even be zero. If a blockchain is not minting new tokens or new balances every single block, then the Genesis block must have an initial balance. Otherwise, there will be no way to introduce the new balance. As you can see in the Genesis block, there's something called a nonce, which is a small string-based number. Here, SHA-256, previous block or block 0, represents the signature of the previous block. Since this is a Genesis block, we are not keeping the signature of the previous block. Imagine in block 1 that A's balance is 9 tokens, B's balance is 8, C's balance is 15, D's is 11, and E's is 17. In this block, there are two transactions that are initiated where E transfers 1 coin to B and C transfers 6 coins to E. As you know, these transactions have happened. The new block, that is block 2, must accurately reflect the new balances in line with these transactions. A new block, that is block 1, is then added to the blockchain, and you will notice that there is a SHA-256 for this block, which is the signature of this whole current block. As you can see, the signature of the block number 0 or sign and is being generated by the digest of the full block. This is the signature of the full block, which is being calculated by SHA-256 of the current block. SHA-256 is a simple hash algorithm, which is a crunch of any length of data into a unique string of a fixed length. This way, if any single digit or letter is tampered within this block, the signature will completely change. It is not possible to reverse to digest a signature to the original input data or original data. This is always one-way crunching. So this way, the SHA-256 is crunched the entire block into a unique fixed string, and we call it the signature of the block. Next, if the new block has been added, the signature of the previous block will go to the sign and one into the new block as a header. The nonce will thus be created that will be guessed by a miner, who can be a person, computer, or server, or the process which is confirming the block. The miner will figure out this number and will update the balances of the addresses. So let's say in block 2, B has 9 tokens, C has 9 tokens, D has 11, and E has 22 tokens. A has transferred 2 tokens to B, so B has 11 tokens now. Similarly, the balance of C, D, and E will be updated, and there are only 2 transactions which are new. Also, for the second transaction, B sends 1 token to E, then E sends 3 tokens to D, and lastly, D sends 4 tokens to A. So, now the transactions may be affecting the balance of the input and are creating the output, which will go here in the block 3. Here, the signer 1 is the signature of the previous block, which goes here, and again the signature of the whole new block is created through this process, which will again go back to the next block as a header. Here, the nonce is a number which is being generated by the miners. These numbers or the nonce should be generated in a particular way through the mining algorithms. It depends on each particular blockchain, but in a general sense, the nonce should be generated in such a way that is truly random and directly proportional to the difficulty of the blockchain. Now, what makes blockchain different? Blockchain has features like no central authority, verifiability and auditability, disintermediation, confidentiality, and integrity and robustness. First is no central authority or third-party intermediaries. The emergence of online banking is made doing transactions a straightforward and less time-consuming process for the end users. But behind the scenes, there are many intermediaries involved in the process that play a critical role as trusted and reliable third-party structures. Involvement of these parties in the transaction flow results in high costs which the payee and payer have to bear. It is human nature not to trust strangers or even our friends, so it is a major point that blockchain is adhering to. It is removing the need to trust third party. The cryptographic algorithms used in blockchains eliminate the need to trust any party. For example, you have the referees in a soccer game, or you have a bank who are helping you to make the online transactions in e-banking or internet banking. Third parties help in maintaining trust, but there is always a possibility that they can tamper with the data. This is the main issue blockchain is trying to solve. In a blockchain, transactions are verified by nodes distributed globally in a P2P network. Anyone can join or leave this network without disrupting the network's ability to form consensus on the state of the blockchain. It is unlike a central server in which a single computer is used to manage transactions. Instead, distributed computation from anywhere in the world can be leveraged. Bitcoin and Ethereum are excellent examples of blockchains, which are used to communicate value globally without any trust in any party and without any middleman. Now let us understand how blockchain provides you with a verifiability and auditability. Any record of the transaction on the blockchain is verifiable by anyone. So, if you are using the public blockchain like Bitcoin or Ethereum, all the transactions happening can be verified by anyone. For example, there is a Bitcoin Explorer that are the web applications built upon the blockchain itself, where you can go and see how the transactions that happened, how much Bitcoin was sent to the person, what was the different period where transactions happen. So everything is verifiable and transparent with the public blockchain, and these records are openly accessible. Suppose you want to upload some data over Bitcoin blockchain, it can be seen by anyone. But to make sure that nobody can see your transaction or data, what you can do is to use your account private key to encrypt your data. If you have an account over the network, and then you can use the private key of that account, or even if you have the understanding about the cryptography, Then you can create your key pair and then use the private key to encrypt the data and then upload it over the Bitcoin blockchain. So it's like whenever you upload the data over the Bitcoin blockchain, it's going to be accessible by everyone, but it's going to be encrypted. So only the person or group of people who have your public keys will be able to take the data and see the data that you have uploaded. So that's one of the ways to upload data on Bitcoin blockchain or Ethereum blockchain. Then it's easy to audit any transaction and its trail, as every transaction is interlinked to the previous one. Bitcoin works on a UTXO principle where every input in a Bitcoin transaction comes from the unspent output of some previous transaction. Then we have disintermediation. Now, in order to verify any transaction on blockchain, you don't need a third party or a mediator, or you don't have to depend on any centralized administrator. All the records stored in a blockchain are verifiable anytime by any peer. For example, to verify the college degree, you have to trust the college servers or the college email which is responding to the inquiry. But by way of contrast, it is not required if the college degrees are verified by the blockchain-based ledger. Next is confidentiality and integrity. The blockchain is an openly distributed ledger yet a private system due to encryption. Many technologies have options to restrict the certain records access based on the user public key or the permission set by the creator of the files. Hyperledger Fabric blockchain offers tons of private and confidentiality features using the certificate authority or CA server. And last is robustness. Extreme fault tolerance is due to involved redundancy and decentralization. In the blockchain network, any server or machine can come and go at any time without informing any of other nodes. That's all for this session. Thank you.